Okay, here we are. Lesson number 4. Lesson number 4, CP3. Get with it. Let's do this. Yesterday, we talked mostly about the circumcenter and finding that point using slope and midpoints and perpendicular slopes to find that. Today, we're going to identify a point and a slope to find the orthocenter and the centroid. So let's get it started. Okay, first, what I want to look at is some information that would be very good for you to write down, considering the circumcenter, orthocenter, and centroid. So here we go. What point would we know with regard to the circumcenter? Right? When we talk about the circumcenter, it's a perpendicular bisector, right? It's formed by the perpendicular bisectors. So the word bisect tells me I want to know midpoint. So I'm going to find a midpoint of the opposite side. Okay. The slope, I'm staying in that column with circumcenter. The slope is going to be perpendicular to that opposite side, right? Perpendicular bisector tells me opposite reciprocal slope. Couple of pieces of information. You're going to be seeking a point and a slope. Why would I want a point and a slope? Because then I can put that into point slope form. Okay, with orthocenter, this one might not be as easy to visualize, but the orthocenter is formed by the 3 altitudes, and an altitude starts at a vertex and is perpendicular to the opposite side. So the point that I know or that I can find is that vertex. This point right here. And then the slope will be the slope perpendicular to the opposite side. So I would find the slope of this side right here, do the opposite reciprocal, combine it with this point right here, and I could write an equation of a line. All right, the centroid, this is a nice one. It's too easy. Why is it too easy? Well, not because it's given, but because if we have 3 points, we use this formula. Do you remember this formula? Y plus y over 3. That's how we'd find the centroid. Right? We'd want 3 points to find that. Okay. So step 2 then would be use this method of substitution to find out where the lines cross. Right. All right, so let's get started with an example. Find the equations of the altitudes to PD and PQ. Okay, so if I want an altitude to PD, here's PD. I want an altitude. That altitude, which will be green, should look like this. Do you agree? Yeah? It's got to go through the vertex, and it's got to be perpendicular to the blue segment. Okay, so I already have a point that I can work with. It's going to be 8, 4. Right? And then I have a slope. Well, I could find that slope by finding the slope of PD. So let's work through this table right here. Q to PD, right? That's that segment that I have over there in green. The slope of the side of the triangle. So that's going to be, in this case, the slope of PD. The slope of PD we could calculate by taking y minus y, so that's 4 minus negative 4, over x minus x, negative 4 minus 0. What is 4 minus a negative 4? 8, good. And that would be over negative 4, so what's the slope of that blue line? Negative 2. Okay, so the slope of a line perpendicular to it, aka this green line, what do I do with the negative 2? Flip it over and change its sign. Perfect. So the equation of the altitude is going to be y minus something equal to slope x minus something. We determined that point earlier that we wanted to use as 8, 4. So I would put a 4 here and an 8 here. And we just determined our slope, which should be 1/2. There's the equation of that green altitude. Would you, with a neighbor, maybe struggle through the second one? I can sketch what you're looking for. Okay, let's sketch what we're looking for. We want to find the altitude to PQ. So I'm going to erase these. Here's PQ. I want to find the altitude. I want to find the equation of that blue segment right there. Okay, so what do I want to find the slope of? PQ. Find the slope of PQ, and then use this point, point D, and see if you can come up with the equation of that altitude. Okay, so I found the slope between P and Q to be 1. The perpendicular slope would be -1. And therefore, I can use this point at D as -4, 4. If I plug them in, that'd be y minus 4 and x minus a -4, which is x plus 4. Those are the equation of our altitudes. So let's find the coordinates of the orthocenter. Right, coordinates of the orthocenter. These two equations I'm going to use to find the coordinates of that. So let me rewrite them in a form that might look a little bit more familiar. The first one, this one right here, which is y minus 4 equals 1/2 x minus 8. And the second one, this one here, is y minus 4 equals -1 x plus 4. Let's put this into y equals mx plus b form. If I did this and I distributed 1/2 to both of these terms, what would I get? 1/2 x, oops, not negative. I'd get 1/2 x minus what? 4. Yeah, perfect. And over here, if I distributed -1, I get -x minus 4. Everybody okay with that? All right. So I want to get them both into y equals mx plus b form, so I'm going to add 4 to both sides. It looks like I get y equals 1/2 x. And over here, what do I get? Y equals -x. Both of those 4's disappear, right? Yeah, so what I'm going to do is I'm going to take this, and I'm going to take this, and because they both equal y, I'm going to set them equal to each other. What's the only way those could be equal? If x equaled what? Yeah, x has got to equal 0. X has to equal 0. Right, so I've got half of my orthocenter. I'm going to try to find the y value. Where should I plug in 0? Anywhere you see an x. Anywhere you see an x. Where is the simplest where you have both a y and an x? This one here? Yeah, the point where they'd cross, you guys, the orthocenter would be 0, 0. If I plug a 0 in here, y equals -x, x is 0, well, that's going to be 0 as well. Okay? Conveniently, this orthocenter came out to be 0, 0. Let's keep moving. Let's work centroid now. Centroid. Find the equation of the medians. What does a median do? If I want to go from A and I want to go over to BC, what did the median do to BC? Cut it in half. Well, how did you know that? Did you look down here and find midpoint? Did you look there? Yeah. Hans, you're not supposed to look down. Oh, sorry. Hans is our new student. Come on. Okay, so I want to find the equation of this red line right here. Guess what? I have 2 points. Those 2 points are A and whatever this midpoint is. Oh, could I find that midpoint's coordinate? Sure. I'd take C and I'd take B and I'd average their x's and average their y's, right? So the midpoint would be the midpoint of B and C, right? So this would be the midpoint of B and C. Let's find the midpoint of B and C. Let's take their x's, add them together and divide by 2. That's a 3 and a -1. Add those together, divide by 2. Take their y's, which would be -5 and 2. Add those together and divide by 2. Is that right? Yeah, that's right. Okay, so I get 2 over 2. What is that? 1. What is -3 over 2? That's -1.5. Okay, so I got a midpoint. Now I need a slope. I need to know the slope of this red line right here. What is the slope of that red line? Well, now I'm going to take the slope between A and this midpoint, which is 1, -1.5. Okay, let's find the slope between those 2 points. So y minus y would be -1.5 minus a -3 over 1 minus a -5. So negative minus a negative, so that'd be plus, so that'd be 1.5 over, what is that, 6? Yeah, chop chop, 6. If you reduce that, that comes out to be 1/4. So I have a slope and I have a point. Okay, now, I actually have a couple choices here. I have 2 points that I can choose to use. Which one would be maybe easier to work with? The one with decimals or the one without decimals? Yeah, let's go without decimals. So let's go without decimals. Let's use this point, -5, -3. So we would take y minus a -3 is equal to slope. Well, what's that? 1/4 x minus a -5. If you wanted to, you could go ahead and make that x plus 5 and that y plus 3. I think I'll rewrite that for those on the web that are watching. Maybe Mark will watch this video and be inspired to become a math teacher, and I'll go into acting. We'll just switch. Then he'll have pictures of Lud all over his classroom. Yeah, Adele. If you chose to, you could use this point right here. That's fine as well. But we needed that point. Some might say, well, why did I even need that point? You had to have that point so you could find the slope of the red line. You needed it. You need 2 points to find that slope. It'd be nice if this were perpendicular, but it's not always perpendicular. So I can't just find the slope of the blue line and take its opposite reciprocal to find the slope of the red line. All right, struggle if you would with the second part of that, please. And then I'm going to show you why the centroid is so awesome. Okay, why it's so awesome. Okay, if you're working on the second part, I want to find the median, the equation of this blue line right here, from C to the midpoint of AB. So I got to find that point. And then I got to find the slope of this line. My bad. I got those flipped. Yeah, here we go. I'm going to find the midpoint there. I had it backwards. Good. So I want to find this point, the midpoint of AC. And I want to find the slope of that line. Okay, so we got this midpoint, right? -3, -1/2. We got a slope of -3/4. And then we use this point B in our equation with our slope of -3/4. Oh, I do not want to set those equal and solve, do you? No. And the nice thing about the centroid is you don't have to. When you see centroid, you should say, thank you. And I will pull out my Moana doll and say what? You're welcome. Because centroid is this. Oh, what are my x's? Well, they're -5 and 3 and -1. And my y's are -3, -5, and 2. And when I simplify, I get, what would this one be? Yeah, that'd be -3/3, which is -1. And what would this one be? Would it be -6? Yeah, -6/3, which is -2. Oh, that was so much easier. I wish they always did that. Centroid is nice that way. Okay, like, subscribe, comment below. May 31st. Be there. Wahlburgers 2018 for life.